Hello everyone. Let's provide the solution to this problem. X squared minus x to the power of root x equals 0. Okay, so if we have this to deal with, we can simply take this negative from root negative x to the power of root x to the other side, and it becomes positive, right? So this means x squared is equal to x to the power of root x. Now, what do? Let's take the log of both sides. So we take log x to the power of 2 equal to log x to the power of root x. And you know what happens to the powers. The powers go behind, okay? So that means I'll have 2 log x to be equal to root x log x. Okay, so this is what we have. And then I was thinking, what if I divide both sides by log x? This will go with this. This will go with this. Okay, but then 2 will be equal to root x. And this means that x is equal to 2 to the power of 2. And this will be equal to 4. So this means that x is equal to 4. But do you think this will be the only solution to the problem? Remember, the equation is x squared minus x to the power of root x equals 0. So do you think it's only 4 that will satisfy this equation? The answer is no. And that is why we are going to solve this in another way to show all the steps. Just hold on and follow it up. Okay, so I will take this to the other side just like I did before. So we have x squared equal to x to the power of root x. Now when you take the log of both sides, you will now be having log x squared to be equal to log x to the power of root x. Okay, this is the same step I took before, right? So this goes behind. We have 2 log x equal to, this goes behind, and we have root x log x. Now what I did before was to cancel the x, I mean log x, from both sides, but we don't have to do that. Now imagine I bring this to the other side. Okay, we're going to have 2 log x minus square root of x log x equals 0. You can see that, right? And then what again? We have log x and log x. So let's factorize so that we get log x as a common factor. Now here 2 will be left. Then minus here root x will be left. And this is now equal to 0. Okay, so from here now we have 2 terms to multiply to get 0. So we can say it is either log x is equal to 0 or 2 minus root x is equal to 0. Okay, so now we are getting 2 solutions. Now from here, remember that if you have a log like this without any base indicated, it means that it is automatically in base 10. So from here, we say that it is 10 to the power of 0 that should give you x. So our x is equal to 10 to the power of 0. That is, if you want to relate your logarithm to indices. That is what you do. Then on this side, we have 2 to be equal to square root of x. 2 to be equal to square root of x. And 10 to the power of 0 is 1. Then on this side, okay, x will simply be equal to 2 to the power of 2, just like I did in the first method. Now x is equal to 1 or x is equal to 4. So from here, we have two solutions. So if you encounter this kind of problem, you do it in this way so that you can have two solutions. Remember, this is quadratic because of this power of 2. Okay, now let's confirm this. The equation is, okay, so let's confirm what we have done. If we say x is equal to 1, then we'll have 1 to the power of 2 minus 1 to the power of root 1. Okay, will this give us 0? The answer is yes, because at the end of the day, we'll be having 1 minus 1 to the power of 1 is 1, so this is 0. So this satisfies the equation. Now let's work with x to be equal to 4. That means we'll have 4 to the power of 2, right? Then minus x is 4, then to the power of root 4. So this means we have 4 to the power of 2 minus square root of 4 is 2. So we still have 4 to the power of 2. And this is giving us 0. So this also means that the second solution satisfies. Thank you for watching.